All right, so here again, we're back to solving for given variables. So this time we want to solve for x. So we have 3x equals a over b. Well, in this case, since we have a fraction here, it might be nicer instead of saying divide by 3 if we multiplied by 1 over 3. So that's going to be what I think is going to be the easiest thing to do. And let's put it over here so it's easier to see both sides. So 1 over 3 times 1 over 3. So x equals, now we have a times 1 is a, 3 times b is 3b. Okay, and we have solved for our x. What about this one for b? Well, here we have to get rid of that 5a, so let's subtract 5a from both sides. So that's gone. So we have negative 7b equals 4 minus 5a. Now we need to divide by negative 7. So b equals 4 minus 5a over negative 7. Now, could we do anything else? Yeah, we could say, well, that's also equal to. Now, if we make that a positive in here, then we could say, well, this is now going to be, instead of a negative, it'll be a positive, so we can write it out front, and that'll be a negative, so we can write it second. So that's another version. We could also have just out in front a negative, and then we have the 4, uh, not a, 4 minus 4 minus 5a all over 7. So there's multiple ways to write it, but if you write it just directly as that, that's going to be one way. This is probably I would say the most simplified form here, and this is a little more complex because then you could still multiply and distribute over cross, which is then what you're going to get here. So those are the different ways you could represent that one. What about this one? We want to solve for R1. So we want this little thing here, but we have all of that here. So first thing we have to do is we have to get rid of that 2D. So we're going to have to subtract 2D from both sides. So that's going to be L minus 2D equals pi times R1 plus R2. Okay. Now we want R1, so we have to get rid of this pi next. So let's divide by pi. So we have L minus 2D over pi equals R1 plus R2. Now we want R1, so we have to get rid of R2. And so R1 equals, then we have L minus 2D over pi minus R2. And that would be a very acceptable answer. Now we could also, you know, plug in and get a common denominator and make it into one thing. So if we did that, if we had L minus 2D over pi minus R2 times pi over pi, then that's going to give us L minus 2D minus pi R2 all over pi is equal to our R1. So that's another version of what we have here. So because this is the first item here we get, I would say this is acceptable unless they say get it into one common fraction, and then that would be what you need there. All right, so a famous one, degrees Celsius and degrees Fahrenheit. So how do we go back and forth here? So we want, right now, this is finding degrees Celsius given degrees Fahrenheit. And what we want to do is find degrees Fahrenheit given degrees Celsius. So we need to get this rearranged. So C equals 5/9 times F minus 32. So we need to multiply by 9/5 to get rid of that here. So let's multiply that by 9/5. So we have 9C over 5 equals F plus 32. Now we subtract 32. And so that gives us F equals 9. Well, we can put 9C over 5 minus 32. And so that would be our actual solution. Um, now, I mean, you can always test it and see, plug in numbers and see if it works both directions, but that's going to be your solution. Now we want to solve this for x. So what do we need to do first? Well, we have to get rid of that 2b. So we have to add 2b. And so we have y plus 2b equals 6mx. Now we want x, so we have to divide by 6m. And so x equals y plus 2b all over 6m. Okay. Again, none of these are hard. We're not plugging in numbers, have to multiply anything or anything like that. All we're doing is we're solving for one variable or another within the thing. We could have solved for m in this case, and then instead of dividing by 6m, we would have divided by 6x, and that would be the difference here. All right, so we'll stop there and we'll come back with this one.